Here we go, more tangent lines. This first theorem that we're going to talk about today says this. If a line in the plane of a circle is perpendicular to the radius at the endpoint of the circle, then the line is tangent. Does that sound familiar? It should, because all it is the converse of what we said yesterday, right? Yesterday we said if it's tangent, then it's perpendicular to the radius. Now we're saying if it's perpendicular, then it is a tangent line, okay? So it really is just the converse. It's going to feel very familiar today, okay? Meaning now the question is going to look a little different, but you're doing the same thing. This says, is ML, so is this line tangent to N at L? Explain. Here's the thing. You cannot look at that and go, yep, looks tangent, we're good, move on. That doesn't work, okay? You need proof. How do you prove that this is tangent? It does connect, but how do we tell that for sure it's going through one point? What?
Like N and L?
No, there's a relationship. What does this theorem say? If it is what? Perpendicular. How do you tell if they're perpendicular? If it's a right triangle. Pythagorean theorem. Okay? So you're going to do the Pythagorean theorem right now. You're going to do 7 squared plus 24 squared should equal 25 squared. If it does, it is tangent. If it doesn't, not tangent. Hannah, don't turn around anymore. Not again. So what you're going to do is you're going to plug this into your calculator and you get 625, and then you're going to plug this into your calculator and you get 625. So if they are equal, we would say yes, it is tangent, and your reason is the work you show to get there. Okay? Yeah.
Well, if we already know the Pythagorean triple.
Then you would just say, yes, that's a Pythagorean triple. Yep. Like, I just need to know that you know it's because of Pythagorean theorem, right? Okay, so what do you do on number 2? Is BC tangent to the circle? How do you tell? How?
5 squared plus 8 squared equals 9.
5 squared plus 8 squared would have to equal 9 squared, okay? So plug that in. 5 squared plus 8 squared is... What is it? 89? 89. 9 squared is 81. Those are not equal. So is it tangent? You would say these are not tangent. So it has to fit in the Pythagorean theorem if it's going to work out, if it's going to be tangent. Okay? Questions on that? It's pretty simple, right? It's what you did yesterday. All right, this next one's my favorite part of 12.1. There's another theorem here. It says this. If 2 tangent segments to a circle share a common endpoint, so here's their common endpoint, point B out here is the common endpoint, then the 2 segments are congruent. Okay, so if these are both tangent, which they are, okay, they hit the circle at one point, then where they meet, the distance to that point has to be the same. So these 2 segments will be congruent. Kind of reminds me of Jack in the Box, if you turn it. I don't know. So here's what ends up happening with this, okay? You will see questions that look something like this. They often involve perimeter because it ends up making this triangle when you connect a whole bunch of these tangent lines. So like this one, it'll say O is inscribed in triangle ABC, meaning inscribed, it hits at exactly one point on each of those lines. So this point right here, this point right here, and this point right here. So all of those are tangent lines. When they say it is inscribed in the triangle, it's saying you have 3 lines that are tangent, okay? What is the perimeter of triangle ABC? So we're looking for the perimeter of this triangle. Okay, well, that theorem says if a point is tangent and meets outside the circle, so like this C right here, the distance to the circle is the same. So can you tell me the value of CE?
8.
It would be 8. If this one is 8, then this one is 8 also. Okay, what is BE?
15.
That would be 15. The distance to the point is the same for both of them. So this is going to be 15 and 15. And then your last one, AF is 10, same as this one. Okay, so your perimeter is really those two 10s, the two 15s, and the two 8s all added together. You can do 8 plus 8 plus 10 plus 10 plus 15 plus 15. That's fine. I don't care how you lay it out. But your perimeter is going to be, add that all up. What does that work out to? Oh, I changed my picture.
66.
Is it 66? Oh, what did I? Oh, no, I didn't. Just kidding. Don't forget to label it, right? It's a distance. Perimeter is a distance, 66 centimeters. Okay, so look at this next one. This one's a little bit different because now they're going to tell you, they're going to tell you the perimeter. Okay, but they don't tell you the length of every side. So what they're looking for is the length of QY here. Okay, so let's just call this X. QY is a length of X. The perimeter is 88. Anyone know how we can solve for the length of QY, Bella?
Put 88 equal to 17 times 2 plus 2 times 15 plus x. And solve for x.
When
You're
you start
so
plug-
close.
When you start plugging in what you know, like PC equals 15.
PC, oh, PZ is 15. Yeah, that's what she was saying. So 15 plus
Y
15,
is 17.
17 plus
So
17.
basically add all those up plus x equals 88.
Nope, that's what she said. 2x. Why 2x?
Oh, yeah.
Yes, this XY, QY, sorry, and this QX have to both be taken into account. We don't know either one of them, so call them both X. So it's going to be 2 times the X's plus those two 15s plus the two 17s should equal what? The perimeter they gave you, 88. So plug that in, you get 2x plus 30 plus 34, so plus 64 equals 88. We're going to take away the 64 then, and we get 2x equals 22. Nope, 24, sorry, mental math. And then divide by 2. So x is 12 centimeters, okay? And if you wanted to double check it, treat these both like a 12 and add them all up. 12 plus 12 plus 15 plus 15 plus 17 plus 17 should work out to 88. Questions on that? Okay, you try this one. Here's your figure. See if you can find the perimeter. This one's a little bit tougher. Not tougher, just a little bit different. See if you can figure that out. All right. Let's hear some answers. What'd you get? What'd you get, Luke? 52. Anybody else get 52? A few 52s. Anyone get something different? What'd you get, Audrey?
I got 50.
50. Anybody else get 50? What'd you get?
I got a 0.
That's not even logical, but good. Means you what?
I didn't put anything down.
Yeah. Okay, well, I'll talk you through it right now. Try and fix that. Okay. Think about what's going on here, because here, I'll tell you the most common mistake I see. People see this and they go, oh, this is the only thing that's missing. And there's an 8 right there. That must be 8. that is not what the theorem says to do, right? The theorem says the points meet at a common point outside the circle. So that 8 meets at a common point right here with this piece, right? So if this is 8, then this is 8 also, right? What is this length then?
3, I will.
That would be 5, right? 8 plus 5 will get you that total of 13. What is this length? Also 5. Those are going to be the same. This is 5. Okay, so then what is this length? To add up to 11, 5 plus 6 will get you 11, meaning this is going to be 6 also, right? So then your last piece here, this is going to be what? 7 to add up to a total of 13. So this one is 7, okay? So your perimeter is 8 plus 13 plus 11 plus 13, not drawn to scale, that's okay, plus 7. Now, the other thing I see done wrong a lot on this problem is people forget where they started and where they end, and then they duplicate or they completely leave off a number. So it might be in your best interest when you use a number to just cross it off. 8, and then 13, and then 11, and then 13, and then 7, okay? If you want to call this side 15 to make that simpler for you too, that's fine too. But you're really just adding all that together, which means our perimeter, I don't know what it even came out to. What was it? 52. Okay? Questions on that? That's the whole lesson. You've got 18 minutes and only like 7 homework problems to do, so you can absolutely get that done in 18 minutes.